Hello, everyone. Okay, so it has been a while. I was abroad, and the time that we usually do our streams was definitely not the right time when it comes to doing stuff in San Francisco. So yeah, I tried to do other times, but with the jet lag and things like that, things really didn't. I never had a chance to do things. But now I'm back in Japan, and yeah, jet lag. I have no idea why, but I can recover from jet lag very quickly when I'm going to Japan. But when I go back eastward to the US, it's doesn't happen. Like right now, I'm like a little tired, so I don't think we'll be doing a full live stream till like 2 a.m. like we sometimes do. But yeah, when I was in San Francisco, I could barely stay up past like 7 or 8 or something like that. It's kind of ridiculous. But I did have a good time over there. I did a lot of things. We went to a bunch of kind of conferences like TechCrunch, Disrupt, and we also did the Gen AI Summit, NEC's Future Forum, and what else? AnyScale, and what else? There was a couple of hackathons that we joined, and we also had our own kind of meetup near the end of the month. So it was quite a busy month. So that's pretty good. Yeah, so now I'm back in Japan. I'll be back here for a few months, so we'll be doing these streams normally again. And yeah, so since I don't have a lot of energy today, I was planning on just finishing up some Langchain stuff that I was doing in circuits, which is good. Maybe doing a little bit of kind of playing around with Mistral as that came out recently, and kind of want to see what it can do, yeah, what the performance is like, and yeah, that's pretty much the plan for today. I don't want to pack too many things in here. I see Freeman is back in the chat, so thanks for coming along, Freeman. So yeah, in VE news, I guess we can kind of like start off with a little bit of VE news. I don't think I have the brain power right now to really do anything on the VE, but I can share some things that have happened. So let me go here. So I've been really enjoying the kind of like browser pin to dock thing that Safari has in the new macOS. I'm using Chrome here because it gets the icon correct, although the icon size is a little weird. But yeah, having apps instead of tabs in a browser is kind of the way to go, at least in my opinion. I'm an old person now, so let me look up the thing I was looking. So when it comes to the VE, seems that Eric, who is kind of the VE guy, has taken the llama.c port that we have done, or that we kind of started with on this channel a few weeks ago, and he has added FP16 support, which is quite amazing. So if we go here, we can see VE Llama 2.c Git there. And it is, it's pretty amazing. I was not thinking that you could do FP16 on the VE 2.0 and get any good kind of performance out of it. I haven't looked at this yet, but yeah, you can get 16-bit models running, even with the Vector Engine 2.0. Getting FP16 running on the 3.0 makes sense, because that hardware is capable of doing 16-bit floats, but the VE2 is not. So I'm kind of really interested to see how he got this branch up and running. So yeah, let's look at a couple of these things. So one thing is, so I think it's mainly for the VE2. I'm guessing it's mainly a memory thing, right? We save the memory or the weights as FP16, and then we can load them as FP16 and then expand them in the vector engine, and then do the actual computation with FP32. But when it can do FP16, then it would do it that way. Yeah, so VE12 do not natively support bfloat16, but here it emulates it and uses bfloat16 weight matrix data to allow using larger models, and that's pretty cool. And yeah, BrainFloat16 is, an interesting case when it comes to FP32, right? Because it has the same what is it? The same mantissa, I think, right? If I'm not mistaken. Yeah, so the 16-bit format is like yeah, okay, so it has the same exponent, that's what I meant. So essentially, when it comes to a 32-bit float, you have this 8-bit exponent, and then you have 23 bits of fraction here, or the mantissa. And then with bfloat16, you have the same 8-bit exponent, but a lot less precision in the fraction side. And so when you're doing the storage, this is where things are kind of interesting, is that if you kind of pack this correctly, in 32 bits, you can fit another brain float here, essentially. And what you can do is, first, when you're loading it, put this to 0, and then do a vector load, right? Like, so you'd have like a kind of a logical operation that just sets these bits to 0 and then loads this as an int. Then you convert that to a float 32, and you're kind of stuck with the precision of BrainFloat16, but you have the full range of FP32, and that's pretty cool. And I'm pretty sure that's what's going on in here. So it'd be really interesting to see that. And yeah, we can see there's this kind of low-level thing going on here. But it's not, it's not a huge change. Just a few intrinsic flags for getting that working, and then yeah, and then after that, you just kind of load it. And if row memory order, okay, and then you also added the row memory order versus column memory order. That's amazing. So it must be even faster than before. So yeah, I think in general, kind of like sticking with BrainFloat16 as the way to kind of do, I mean, it's not like the normal kind of quantization, because quantization is kind of going with int8 and stuff like that. And we're definitely not doing that here. Could be doable to save good amount of memory to have running things in bytes, but I'm not sure if loading that will be very, very efficient or not. But if you could, that would be pretty good. So essentially, the cool thing when it comes to BrainFloat 16 and loading is that the mask that you have to do bitwise is perfectly vectorizable. That's like a vectored operation. So there's a nice operation to mask the top. There's vectored operations to shift, right, to the right place, to the left. And then there's vector operations to expand and contract, right? So all of that stuff is done vector-wise. When it comes to working with bytes, however, it's a little bit more complicated because I don't think there's no vector byte level instructions. So you have to work essentially in 32 bits with 4 different values. So you can do it. It's just like, you're doing a lot more work, right? You'll have to mask, then shift, then mask and shift, mask and shift. So yeah, I guess it'll be pretty much. I mean, it's going to be pretty similar. So yeah, it is very interesting. Wish I had a VE 3.0 to try it out. But definitely check out this branch of VE Llama 2 on the XX Aurora repository for those of us that are VE friends. And yeah, that's that. But like I said, because of kind of remaining jet lag, I don't think I have the brain power to be going into bit tooling floats and getting that. Though it is an idea for a later stream. So Mistral, which I have running here on this H100, is a new model. That's it's a new model that is a little controversial, but pretty good. And I mean, I don't think it's definitely not the best model out there, but it's pretty good at 7B. Right? That's the thing. So I'm really interested to see how it does if you give it a lot more memory. 14B might be really interesting. So really looking forward to that. So I happen to have a new H100 machine here, and since I had nothing else to do with it immediately while we're waiting for some stuff, I decided to give it a try with some Mistral Instruct. So we'll do that here. This is using the Transformers library, so it's not very fast. Particularly loading can take a really long time, so it'll take a while. But this is just a simple kind of wrapper around Transformers where I kind of do an initial prompt, let it do its thing, and then it comes back and then has a user prompt here that I can talk to. I can also do :reset to reset the conversation, and now I'm dealing with a completely blank conversation. Yeah, it is quite a neat machine. So we do HTOP here. It's about 22 cores. Has 224 gigs of RAM, and it has a H100 PCIe, which is pretty neat. Okay, and so let's see. If I say like, "Hi, can you help me with my homework or something?" My programming homework. This stuff that gets spit out to the standard error, I cannot do anything about, or at least I have no idea how to do that. So just ignore those, but everything after that, that's the output of the network. So I can say, can you show me how to write a prime C in Python? And yeah, right now we're getting 98% utilization on the GPU, so it's pretty good. It doesn't stream, so it's kind of hard to feel how fast it is without streaming, but yeah, it's a good number of tokens. The output is nice, right? So here's an example of privacy in Python. It's pretty decent thing. And yeah, and this is just a regular instruct model, so just a fine-tuned model, pretty decent. We can kind of compare it side by side between. Let me bring Technologic in here. Okay, so let's put that there, and then we have Technologic on the right-hand side here. Yeah, so we can kind of compare it with GPT-4, or if we wanted GPT-3. Let's compare it with GPT-4. So if I set the same thing, help me write a privacy in Python. You can see it has pretty different implementation, but more or less the same kind of idea. You got true times that and some other things. And what was the thing I asked it before? I had some like computer thing that I was asking. Was it again? Something simple. Yes, this one. This not that. Although that one's another one. Yeah, I was thinking, I couldn't remember the name of the method rfind, and so I wanted to delete up to the last instance of a string for this, but I could not remember what the name of the function was. So I just wanted it to say rfind, and if I do that with Mistral, you can see it's in here. There we go. Yeah, and the cool thing about it didn't do it this time, but the cool thing that it mentioned here, which this didn't mention, was that if you wanted to remove the hello and hello again, you need to keep that into account. It didn't mention it or anything like that. But yeah, when I did it with Mistral, it worked pretty well. So that's nice. There's some potential here. But I do think it is limited by just having 7 billion parameters. It's not really enough, or perhaps we just need to kind of give it more room to think when it thinks of things, which is something that people have been working on. Yeah, pretty cool. It's pretty fast, so I like it. And it should run pretty good on the vector engine as well, because the sliding window is, as long as it fits in the L2 cache, that's going to be pretty great in terms of performance. So yeah, maybe next week or so, right? Not next week, but sometime this month we'll look into getting this running. There's also a lot of interest in getting Stable Diffusion running on the vector engine, which I think we can do. And one of the things we kind of thinking of when it comes to that is GGML. We could maybe port it, and then that would get us a lot of things, right? If we could port that and then just use that as a library instead. But I'm not sure how involved that will be. But anyway, so that is Mr. And that's all the things I kind of wanted to show there. So let's bring Technologic and Mr. out of the way. I am planning on adding Mistral into the XI LLM server so that we can kind of have that as a service for people. So keep an eye on that. I'll make an announcement on either the Twitter or in our Express AI Discord. Okay, excuse me. Anyway, so let's get to the Langchain thing. So for those of you who do not know, Langchain is this interesting library that allows you to do things with LLM APIs, essentially. Works pretty good. And I never really liked it all that much because I feel like it adds way too many layers of indirection. And because the way I work, I kind of need to see how things are working at a low level before I can feel comfortable doing it at a high level. I never really liked just like how many layers there were in Langchain for what it does. But it is a popular library, and I kind of wanted to see how it would look like if you had Langchain in circuits. So I have started that. So this notebook shows some of the APIs that are available in their tutorial, and just simple stuff. So I started making a component library for it. Here you can see there's this Langchain chat OpenAI model or Langchain OpenAI model, and there's others, and we can implement those. But essentially, you need to set some sort of model, and then you can use model predict to just prompt it like you would prompt ChatGPT. Really simple. And then there's templated messages. So this, you can say you are a helpful assistant that translates input lang to output lang. And then we can have some sort of human prompt here. So this has created a conversation like messages. And then you can supply then I made this expand templates where you supply a dictionary, either as a literal or by reading it somewhere. That allows you to set those values. And now you have a messages with all those variables expanded. And now you can do predict messages to do the thing. So essentially, it first starts with translating I love programming into whatever output lang you want, and here it's Spanish. Then we do extend messages, which allows you to just add another prompt into some messages. So I added this one, and then we continue. So that one was a easy set of components to add. One thing I'm not so sure about is this model port. It's optional, so I essentially set it so that when you call that first OpenAI or chat OpenAI model, this also sets it into the context. So if you don't supply a model here, these things will take it from the context. That way you don't have to like connect this to everything. But yeah, it would be easier, I think, for people if there was no model port here. But at the same time, if you wanted to switch between different language models, you can't do that unless you have this port. So for the moment, I'll leave it in there, but it might be better if you could do something. Yeah, if it could do something, like optional in a way where you could add it. But that's something for later, like something like low level inside of circuits. And I've actually thought about, since you guys have brought it up, like doing like a stable diffusion pipeline in circuits is also a thing that I've thought about. Haven't really got into it, but yeah, it's totally doable. You could kind of have an entire pipeline where you do different prompts and then do some things with Stable Diffusion, and then have some effects or post-processing as a workflow, and then upload it somewhere or save it somewhere, and then you can totally have like a Discord bot where you can say something and then have this pipeline run. So I think that would actually be a good idea, but I just didn't have the time to do it. That's totally something that could be done. So if anybody's interested in doing that, feel free to make that component library. It wouldn't be too bad. Anyway, so just getting the messages in this here doesn't really gain us anything because we already had the OpenAI component library here. So it's kind of simple. So the next step is to add support for documents and loading documents. And then from there, it should be possible to put those documents in a vector database. And then once that's done, we should be able to do the thing that most people use Langchain for, which is to create agents using the React framework or things like that, and looking up things in the vector database. So to the question about have we tried Whisper, so I haven't tried Whisper yet on the vector engine, but definitely am interested in doing that. When it comes to like one API, I think there's a university thing that ran one API, but I'm not sure. I remember reading a paper about SYCL implementations of vector engine, and I'm not sure how compatible that would be going from PyTorch, because I think it was just like a grad student working on some samples is the level that I think it might be at. So I don't have too high of expectation on that working, but it might if one API is particularly well implemented. It might work as it is. But definitely something that we could try, and it would be nice to have like one API as the API to build things for vector engine. Not sure if it could take advantage, of all the vector engine features or not, but it might. Okay, so I've stubbed out the different things that the next things that I wanted to work on, which is these data loaders. And then we can do the FICE vector store, and then a vector store similarity search. And of course, after doing this, we'll replace those with vector things. But anyway, let's get started with this unstructured HTML loader business. So for that, go here and give it a try. Let's create a new window, and usually I go through the docs and see what stuff they have. Oh wow, they made this a whole new website. Speaking of which, if you haven't noticed, ExpressAI has a new website now. I think it looks nicer. Still a few things to go when it comes to content, but I think it looks pretty nice. And I'm kind of like digging this grid paper background. And I'm kind of thinking, mainly because I'm a light mode person, right? Like my terminals are white, as you might have noticed. And they're white because the web is white, and I don't like switching between like dark and white. My eyes are too old for that. So I like to keep everything the same color. So when it comes to circuits, we don't really have a dark and light theme in circuits, right? But I think we'll take this background and make this dark background, and then later on make for the light one, it would be the same as this kind of grid paper or dot paper kind of background. I think that looks pretty nice. So anyway, yeah, let's look at some docs and see if we can implement a couple functions until I get tired. That's the plan for today, because we need to get to retrieval before we can get to chains, I think. So let's do this. One thing I'll say for sure is that Langchain's API is much more friendly it's much more friendly to something like circuits than Llama Index. And I think it's unfortunate. But anyway, okay, so there's text loader here. Let me see, did we have a text loader? Text loader. Okay, yeah, so I've implemented the text loader. So I think that works. And then we have the directory loader. And I don't think I've tested that yet. So I should probably start by testing it. So anyway, so after we have done this messages, let's give ourselves some space and use some Langchain text loader. And for the file path, I think we'll just use this current working directories. Is this big? No, it's not big. Let's just make the code work with the current location of the source code. So we have this as the working directory. Okay. Then we can do XAI components, XAI Langchain, and Langchain components .ui. Okay, and then let's pretty print the results and see what we get. Let's save, compile it, and run. CSV loader does not exist. Ooh, that is interesting. We can get rid of that now. But I kind of really like that idea of having a CSV loader. That's kind of disappointing. Check those. The stream's looking quick. Pretty good. Okay, cool. So seems like that text loader is working fine. Let's see what's next. Let's do a test of the directory loader. So the directory loader is an interesting one because you can give it a custom loader class. So if we put this as text loader, gotta be careful with new lines there. And then for the directory path, we can just put this directory here. And then for the glob, we can put that as star.py. I think that will load all the Python files, if I'm not mistaken. And we can also have some loader arguments, which I think is used mainly for char set and stuff like that. So let's pretty print that. Give that a test. Okay. I wish we had a different compile dialog. That's fine. Okay, so that does look like it is working, so that's good. So now that we're able to load plain text files and load a directory of plain text files, let's try loading some HTML pages. So here in HTML, there's the unstructured HTML loader, which kind of works like that, and then you load it. Seems pretty simple. So I think we'll take in a file path, is what I call it here. Yeah, path in arc string, and documents, which is an out arc string. Should return none. Self.file path.value, and of course, ChatGPT can totally make all of these components, but today we're going with a hand-flavored component library. Okay, that's just loader.load. Okay, so that should get us some unstructured HTML, which I'm not sure if I have any like just lying around. But yeah, that should work perfectly fine. And similarly, the same kind of thing goes with the BS HTML loader using beautiful soup, except the name is different, which should be BSM that. Otherwise, it should be the same. Okay, the structured markdown, that's something we do have quite a bit. And it pretty much works the same way. So if we copy this to that, and then instead of BS HTML loader, we use structured markdown loader. That should work. The PDF loader, that's the more interesting one to me. We definitely have PDFs around, so let's do that. Load and split. Okay, so that's slightly different. So for this, we're going to do the PDF loader. And this will be load and split. And that gives us pages, which kind of makes sense. Okay, and then for the vector store, we have this sample. So we have fice from documents. Then we can do OpenAI embeddings, which is, it makes sense. The thing is, with the way that we do things in Vecto, which you don't know, vector databases are so hot right now. But the cool thing about Vecto is that you just send us the data, right? You don't need to vectorize it yourself. We vectorize it on the Vecto side. So when you create a vector space, you specify what model you would like to vectorize data with, and then you just send us the data. Langchain kind of assumes that you're vectorizing on that computer instead of vectorizing it on the fast machine. So yeah. But anyway, I think we can copy this into what we need. So we have FICE and OpenAI embeddings. Should be good. Okay, and then if I remember correctly, we need FICE from documents. Get this working correctly. Okay, and then I think we'll need documents in comp arg of list, and then we'll have the index as the out arg of something, be some object, I guess. Because I'm not sure if this thing has some sort of interface or base class, like an ABC that it extends from. So for now, I'll just put objects. That should work. Self.index.value is equal to self.documents.value. And then this should be, specifiable. So put the embeddings class as an int arg string. And what we'll do is embedding is equal to that if self.embeddings class, or I think we should call this CLS. This is what we're doing in other places. Embedding class is not, or is none else. Self do eval self.embeddings class value. Okay, then we should be able to pass that along. Now we have an index that we can do similarity search with. And should be something like that. Execute self-ctx. So we want to do that. So I think we'll have a index in of some object, and we'll need a top k, which is an in comp arg of int, and the documents is an out arg of list. Self.index.value.similarity search, and then we'll need k is equal to self.top k.value. Then we'll need a query. Of some sort. And then we'll put the self.query.value. Let's do a refresh here to see if that loads. Okay, it does. So let's do some testing. need to do some ellipsizing there. Okay, so we'll load a PDF. And the PDF that I've seen recently is this one, which is quite interesting. It comes from Google, called Prompt Breeder. And I know this works because I've been experimenting with something like this. So yeah, I would say the thing that, so having like a prompt be automated where you're like, here's a prompt, try to make a different prompt with similar meaning but not using the same words, and then automatically taking the result of running that prompt and comparing them. Is this better than this, right? And then having the language model choose the better one, and then doing that iteratively. That's not new, and I think there's one of the citations does that. But what's the interesting new thing about this is that it's essentially kind of combining genetic programming and like genetic algorithms for learning and this approach, and that's actually a pretty good one. I might borrow it or give it a shot with the other things that we're doing in the mind framework side of things, because that could actually be an interesting way of like doing more learning in a way, you know, like if we have certain things working better than the other, like having that signal become stronger and then the other alternatives become weaker. We're talking about like simulated brain regions here, so that's something that I could kind of see that working, where we could take the experiences of things and the rankings and then adjust the mind frameworks, like weights, or maybe not weights, but yeah, like do the genetic thing, start pruning the bad performing ones and then merging together more better performing ones. So that could be a genuine thing. Although when I say that sounds like it is a genuine thing. That's like obvious. Anyway, so let's try to load that PDF in particular. So I will copy that path. Okay. Let's do that. Need to figure out how to get that bug to happen often enough. Yeah, so let's take this PDF and let's see what we get. Documents is a string. That is definitely not a string, so let's fix that really quick. Documents should be an outarg of list, because we're splitting. Although I might look at this later. But anyways, let's reload this node. Now we have a list. And for each, we have for each items. And I noticed that this for each is not in the standard library. So my apologies for that. I will take it out of wherever it is right now and put it in the standard library. I think it's, for me, it's in my branches, but I think we haven't, I forgot to push that to the main branch. Okay, so anyway, so what we'll do in the body is to pretty print each particular item. Sounds good. Save that. And let's see how that works. Yeah, Intel is going pretty hardcore on the AI things, and that's good. I really like the new processor architecture that has the NPU inside, and yeah, that's going to be a thing. That's going to be a good thing. So, because like even with the M1 and M2 chips, right? Like just having the neural engine in there is very useful. As we can see, there's like, people running incredible models with just their laptop. So yeah, in our agent future, your laptop is just going to be running agents all day anyway. So having it be able to do that and not kind of freeze your screen while it's working is kind of important. So like, for example, in this laptop, I can totally use the GPU to do deep learning things. But if I have an external monitor connected, the way this particular Intel Mac works is there's the Intel UHD and the AMD Radeon Pro 5500M, which has 8 gigs of RAM, so that's actually pretty good. But when you have an external monitor plugged in, it's going to use this GPU for the visuals, no matter what. It's just hard-coded to do that. And then if you disconnect it, then it will use this. And so what's interesting is that if I set up GGML to use Metal and use the GPU, if I'm not plugged into an external monitor, the graphics is using this, and then the machine learning is using this, and that works great. But if I happen to have an external monitor plugged in and this is being used, the screen kind of freezes while it's doing a lot of the loading and stuff like that. So yeah, it's just better to have a dedicated NPU for stuff. That is just the future. That is the way. Yeah, it makes total sense. And it's a shame that it took Apple to show Intel how it's done. Okay, cool. So now we have a bunch of PDF pages. That looks pretty good. Cool. Okay, so now that we have printed out those pages, let's continue. Let's go do the next step, which was Langchain Vice Vector Store. There we go. Okay. Now I so wish we could have a drop down here. Really need to rework how this system works so that we can have a drop down instead of a string. So essentially this needs to be Open AI embeddings, if I'm not mistaken. Let's double check that. Yeah, it should be this. Embeddings. Okay, so that gets us the embeddings, and then the documents for that PDF we'll put here. Okay, so now that we have the vector store, we can do a lookup. Not a vector lookup, similarity search. Put the index there. Let's say we want the top 3. Okay, and then for the query, we're going to let's just search something simple like genetic algorithm. No. Genetic optimization. Okay. Why are you crying, Freeman? I didn't get it. Okay, let's have the documents. Let's pretty print the result and see what we get. That did not connect. What in the world is causing that to not connect every once in a blue moon? It seems like it's like random, and it only happens on like Macs or like my Mac. Okay, opening embeddings, embed documents. Missing one required additional argument text. Ah, yes. Would work to actually implement the similarity search. Okay, so this thing, embeddings. Oh, are we dealing with not so great documentation? Let me look at this real quick. We are, let's run that one more time. Okay, from texts. Are you serious? This is just like Langchain bug where, hold on a second, that can't, that's like too stupid to be that. We are at 602. It's a list of string. And here we have created it from the documents, and the documents set there along with the embedding. Embedding metadata, documents, embed documents, and has no texts. Vector store 602 should be here. No texts. Does have a text which is set there. Or no, it's set here. Embedding.embed documents texts. Missing positional argument. That mean it's null? Documents are here, they are connected. I don't think they'll be null. We have printed them anyway. That should work. And is it because the it's like a Langchain like internal thing where PDFs are different? They don't have text or something like that. I guess that could be a thing. Okay, we have things. Text embedding. Okay, page content. I see. So let's go up here. Do these things have page content? Yeah, page content problem. Page 62. D in documents. So it would be none. It would be an empty list if it wasn't. Let's do a quick sanity check of here. So print self.documents.value 0. Let's give that another run. Yep, totally have page content here. Either something very obvious and I'm too tired to see it, or there's something other interesting. So we have our class from text. This is inside of Langchain, so we probably should assume it is correct. Then this text is missing. Apparently. Texts, which is here, which comes from there, is missing how? Or embedding. Okay, so maybe we're using this wrong. Like, yes, the documentation says this is how it works, but it's not always the most accurate thing. Okay, so embeddings has some stuff. We are looking at, so embed documents should be doing that. Why are we in JS API? It's an array of documents. Can we see the Python version instead? And I have to specify the OpenAI key. Should have that. So that should be fine. Deployment. Model. Text embedding Ada 2. Did that go away? I don't think so. Just double check that. Yeah, text embedding Ada 2 is the default. So it couldn't be that default has changed. And now embeddings. What am I missing from this error? Embed documents, which is the embeddings. Validate unsafe embeddings, embed documents. Embed query. We are seeing a problem in embed documents. Let me see if somebody has run into this weird ass issue. Ah, okay. Yes, that makes total sense. You need to, yeah, we are evaluating this. We're instantiating it, but here we're just not instantiating it, so we have to call that. Okay, that makes sense. And we need some stuff. Okay, I can install stuff. So you dump the FP32 fast inverse square root hardware. What do you mean you dumped the fast inverse square root hardware? I feel like I'm missing a message or two. Let me check what's on Twitch. Where's my phone? Twitch stream here. Twitch. Can I not see the history of the chat? Why is that? Oh, interesting. We have 4 more followers until 30. Pretty great. Okay, cool. We finished this. We got some results. Calculated all the FP32s and dumped them to disk. Yeah, yes. That's a thing. There is a finite number of FP32s, and if you have the disk space, it's something that you can totally pre-calculate and look it up from the disk. That can work. Definitely something that was done a lot in the 16-bit era, but it's kind of sad right now if a computer can load some ridiculously huge table for memory faster than it can calculate something like that. That is the case. That is sad. Okay, so now we are able to do our similarity search. And yeah, that's good. We should be able to do this with Vecto as well. We might need a Vecto embeddings thing. So with Vecto, since you let the server do the embeddings, essentially we'd have to have like a no-op embeddings class, which should be fine. Anyway, so now we have that. There's a few more things. We have marked down JSON. I'm not sure if JSON is something we can like do. And this is fine. I don't get what the text content equals false thing means. Then JSON lines equals true. I see. Yeah, we can probably do that one. JSON lines are a thing. So let's do this. But I don't have anything to test this one with. I don't think I have any like big Langchain JSON loader. File path, documents, then we want JSON lines, bool, default to false. And then we need a JQ schema. In comp arg string. Okay, and just want to do the JSON loader with the file path. Let's do it the same way as that, because I'm not sure if that will come back and bite us or not. I'm not going to test it per se. That is the file path. Then we also want the JQ schema. Self.jq schema dot value, and text content is equal to false apparently, which I need to figure out what that means because that doesn't make too much sense. False if JSON lines is none, else self.json. This is something I write so much, I kind of wish there was a shorter way to do it. And then this one is not a load and split, but just a load. Content key sender name. We need content key and JQ schema. In what case would you want to do that? That's true, Freeman. There are a finite number of P64s. You're just going to need a lot of memory to represent them all. A really good amount of memory to represent all of those ones. A metadata function, that is doable, but that would be quite involved. So I think we'll skip that. It should be fine for most use cases. Okay, so now that we can store things in a document and retrieve them, we need do we need a retriever to make a chain, an agent chain? Chat message history. It's kind of dumb. Memory and Langchain. That's true with disk space is getting there slowly, and yeah, if you pay AWS enough money, they'll give you enough space for that. I mean, you could, like, yeah, there's MapMol. The state space for MapMols gets really big very fast. But let's say you're doing a 4x4 MapMol kind of thing. And let's say you're doing a 4x4 MapMol cache with 8-bit values. That would still be pretty big, since you can have essentially each cell be one of 200 of, between -128 and 128, or 0 to 255 to the 16. Yeah, huge. Absolutely huge. You could do it, but unless you happen to know that like a serious amount of your values are like very similar, like exactly the same, so that you don't blow your cache essentially with the cached values, you could probably do that. Though I do wonder if there's like some kind of interesting way to get about that with a vector engine, like have a vector engine be a little bit more systolic-like in its implementation. No idea if that would work or not, but I have ideas where you could like use the different cores to essentially kind of be systolic in nature, like similar kind of idea, but just kind of one core passes it to the next core. Not sure if GMMM is implemented like that right now or not. But anyway, I think we'll do a couple more things. I think I'll end the stream in about 30 minutes because it is quite late for me. Let's see. So we have our prompt template. We want a conversation buffer memory. I see. So we can make an LLM chain that has a memory. That's totally doable. Okay, so let's do add component Langchain LLM chain. And it would take in an LLM, just some object thing. Oh, you make a good point. Like an int 4x4 matrix as a cached lookup kind of thing. Because yeah, we totally know that there's plenty of models that kind of work fine with int 4 quantization. So yeah, that could be a thing. Might be a way to implement that kind of quantization in the vector engine. Not sure how you kind of vectorize that properly, but yeah, could be a thing. It might be like doable with four masks for every value, and whether or not it can do 4 masks, like 4 int masks, faster than the floating point calculation is an interesting question. Okay, so we have LLM chain. So what we want to do is make LLM chain, which has LLM a prompt, and then a memory. That memory is an object. Okay, and then once we have that, so let's forget what that is, even though it's simple. Component as a class, Langchain LLM chain predict. Yeah, they call it predict, so we're going to call it predict. Then it will take, so this thing will output, call this a chain, arg object, and this will take the chain, which is an in arg object, and we have a human input. Also be required. Yeah, and so we should be able to do that, and it will like remember things. It should be something simple like self.chain.value.predict self.human input.value. Result arg of string. Okay, so doing it this way means you don't need to do the appending that I was doing. You just keep sending things to the specific chain. So if you create that chain and then save it to a variable, you can kind of continue on to that chain every time. That's good. So we have the question: when using the VE compiler, there's no need for explicit device offloading via OpenMP. Yes. So when you're programming a GPU using CUDA, you kind of have the ability to have both host and device code in the same file. And with CUDA, you specify, __ global to mean that this is a function that you can call on the device from the host. And the way you can program the vector engine is either you write C code that just runs on the vector engine because it's a full CPU, right? Like the predecessor of the vector engine runs a Unix operating system just fine, right? So it has the ability to just like run normal code. So you can build a regular executable that you VE exec to get it onto the machine, and then it's running, and it's just a Linux process. So the way the driver works is a Linux process ID is created, and if you do things with that, you can. So that system or the application can open a socket and listen to things. So you can connect to it through TCP, and then that gets forwarded, or you can have it wait on a Unix domain socket, or look for a file and just load that file and write the file. That's a perfectly valid way of using vector engine. You don't necessarily need to have the host CPU for anything. But there is also the VE offload library, which allows you to call functions on the vector engine in a remote way. So you say you can create a function that should be running on the vector engine, and you reference it with the name by string using a C API. You get a reference to that function, and then you just call with specific arguments. When you do it that way, the vector engine is running this server that can accept connections from this host process, and it sends these messages in and then gets the result out. And there's also Vita, which does things in a more CUDA-like fashion. So you still using VE offload behind the hood, but it's just like a more kind of interesting API. But yeah, it's interesting because you do have the ability to run a single program on the VE, and it interacts with the rest of the system like if it was the CPU running thing, essentially, which is pretty great. It allows you to have a lot of flexibility in how you design your applications. Okay, so let me finish this thing here. LLM chain, and then LLM is equal to self.lm. Then we want a prompt equals self.prompt.value. Verbose true for now, and memory equals self.memory.value. And yes, you can totally do MPI stuff. Yeah. So how does the host memory and device memory interaction work when it's compiled to run on the VE? That is a very good question. So, so the VE has its own memory. So when you're running a program and you malloc memory, that's vector engine memory. You can address host memory with the VE using a DMA call of some sort. Let me see. Engine host member. So I think there was some documentation on how to do that. But yeah, you can, and it's essentially you can do that, but you do have to set it up with VE offloading, right? So like if you're just doing the just runs on the host machine thing, it's a separate process, so it doesn't have access to the host memory per se. But if you have the permissions in Linux set up correctly, and you're using VE offloading, because with VE offloading, your host program is here and the vector engine is here, and the host kind of owns this vector engine process, but they're communicating via a queue. And essentially using VEO, you can have a read host memory thing, where you just kind of give it a pointer and it sends this pointer address. I need to read the memory here to this process. And then there's a C function that just kind of takes the value from this process perspective of that thing, and it sends it over the wire. So yeah, you totally can. But it can get a little complicated. And the other thing is you can do nmap, right? So like if you do an nmap of the file, and you nmap that into both processes, they can do the regular Linux or Unix IPC stuff. They can talk to each other through that buffer, and the kernel kind of handles moving it back and forth. So by pages, it's pretty nice. Okay, so we have an LLM chain. And text, question, answer. Load QA chain. Then we can run that chain. And is that different from chain.predict that we were looking just here? Like, is that the same thing? Is it different? Who knows? Why do they have to tell you? Or maybe they do. I don't think so. Load QA chain. You can do that, and you get a value. And everything else is using classes, but yeah, QA chain, no, fuck classes. It's a function. Makes no sense. I don't get it from an aesthetic perspective. Like here you have a prompt template, and here you have conversation buffer memory, and here you have a QA chain. Why is it a function? Like nothing else of all the things we've been doing is a function. Why is this one a function? I don't get it. Okay. So we need conversation buffer. Keys, chat history. I see. Oh yeah, that is totally a thing, right? Like the fact that in the M1 the CPU and the neural engine and the GPU are all using the same memory, and it's fast memory, is a significant kind of advantage to the M1 and M2. And yeah, vector engine says it's HBM2 memory. It's kind of like has that advantage too. So okay, so we already have a prompt template, and we need a conversation buffer memory key and input key. Okay, we can totally do that. So many things. And I'm gonna try this with predict, because if like this whole this is a function, this returns a function thing is just the same as predict, I'm just gonna stick with predict, because you know how OOP works. So you have Langchain make QA chain. I guess we should call it load. And it needs a model make it required right now, and chain type, let's make that an optional thing, so stuff will be the default, memory, and we also need a prompt. And this chain is the out arg. Okay, so let's essentially do this thing. So self.chain.value is load QA chain. Let's indent it in a reasonable way. Okay, so this is that if self.chain type value is none, else so else self.model.value. Kind of weirdly opposite from normal things, but that's fine for now. Chain type stuff, if self.chain type value is none, else self.chain value. We have the memory and the prompt. Okay, and I think predict should work. And what we'll need is a conversation buffer memory, which I think we'll put it here. Okay. And needs a memory key. needs an input key and a template. Prompt has to be a prompt template. Did I have a prompt template up here? I think I did. Yeah, extend. I have a chat prompt template. I don't have a normal prompt template. Even though this seems like it would work perfectly fine with chat template, we do need a prompt template, which will make things a little weird. Now let's keep it together over here as I work on it for a few more minutes. Okay, we have conversation buffer memory. Execute. Okay, so the conversation buffer memory, Langchain make. There we go. This is the out arg object. So conversation buffer memory key. Also need the input key. Template. Then we set self.memory.value to this. Okay. That's pretty good. And we need a prompt template. We do. Langchain make prompt template. So much fun. Okay, and then the prompt template has input variables. List. String. Then the template, which is an in-comp arg string. It's more or less all you need. And the prompt template is the out arg object. Template is equal to prompt template. That is self dot input variables equal to self input value, and then we also need a human key. Or no, we need template. Prompt, or did I forget? That, there we go. Okay. Actually, x86 has adopted a shared memory model. So there's this thing called the Intel Xeon Max. Is that what it's called? Yeah, these Max processors. So these Max processors have HBM memory just like the vector engine. And they don't need any RAM. Like, you could just boot them like this. So yeah, that could be a thing. It's not a lot of RAM, right? But yeah, since it could work, I think it's pretty decent. Okay, let's test out this last one, and I think we'll call it a day today. Input variable. What was the problem? So we don't need that comma there. I'm going to do this restart. Let's open up that script. There we go. And then I have to find what it was I deleted just now. Which is here. Okay, now, damn it, let's close this. Langchain make prompt template, and let's copy the prompt from here. I'm not sure if this will work. There's multiple lines. And we do support multiple lines in the latest versions. It's just I'm using a kind of old version for really no good reason. Okay, so we want context, right? Let's copy this. Okay. So we have the prompt template. We will make the conversation buffer memory. And this conversation buffer memory wants to do chat history because that's where it wants to put its stuff. And then the input key, which is the same as the other template. And this one, it's human input. template comes from here. I'm not sure if this is a type check thing. Let's try it again. Wasn't a type check thing. And now we have a memory that we can do to an LLM make chain. Okay, and LLM was an temperature. Let's get the model here. So get the model real quick. OpenAI model. Okay, set that there like that. Let's set this here like that. Okay, and then the prompt in the example was. Oh, the prompt template. Kind of makes you wonder, why are we doing this so many times? And then we have our memory here. And I'm pretty sure we can predict. You need LLM chain predict. Set the chain and the human input. And this example was this. Let's do it one more time. Pretty print the results. Like so. Cool. Now, it's not connected to any database, though, which is shown here. So we have chain input documents as docs. Do we have input documents here? Not 100% sure. We'll have to look at that another day. The Xeon Max is quite expensive. Not the most expensive thing they make, but quite expensive. Okay, template here. So I think I need all of these. And it might be that OpenAI is different than this OpenAI. I don't know. We're good. It's the same. Save and rerun this. Yeah, waiting is definitely one way to make things cheaper, although I feel like I kind of want to upgrade my servers to like a better processor, like I think the 48R. So the 8348R is what I can update things to. And yeah, those things are not coming down in price right now. It's quite annoying. says LLM chain is not defined. And of course, it actually isn't anywhere. We can get it from here. And I think regardless of this, whether this works or not, we'll be having none is not an allowed value. Darn. Okay, well, I will leave you guys on that cliffhanger because it's quite jet laggy tired for me right now. So yeah, hopefully you'll see, like, you got to see how Langchain kind of does its thing, and with circuits it really does look like a chain, because that's about as complicated as Langchain gets. So yeah, so that's all. So thanks for coming out and hanging out while I finish up some of this Langchain work, and I will see you guys next week. I think Paul will be working on adding tool support to Technologic. He's kind of started it a while ago, but never got around to finishing it. And since we have kind of cooler open source models now, we kind of do think it's probably time to add that feature in there so we can test all these other models that are out there. So yeah, I think that'll be it. I'll see you guys next week. Talk later. Peace.